like to put on the table for some discussion later, and that is whether the so-called softer sciences, social sciences are generally called the softer sciences, are inherently more vulnerable to invalidity. Let me explain gravity. Gravity is the attraction of black objects. You see this clip? The attraction of black objects by white objects. I will explain gravity this way. If I release this object in space, it'll go toward the closest white object. See it? It's true. So we explain gravity by looking at the black object and the white object and assuming that the white object will attract the black object. You have any problem with that? Well, as a matter of fact, there's a rival hypothesis. There's another way to explain gravity other than white objects and black objects. And in fact, if I really make much of an article of faith about this black and white object thing, I am dealing in what? Invalidity. That's an invalid assertion. But my point is that you can make invalid assertions in hard science, because there's nothing more squarely in hard science than gravity. So I just did it. I made an invalid assertion in a hard science. In fact, all science must be concerned about validity. Or have you never seen commercials for patent medicine on television? I don't know of many fields that deal more thoroughly in invalid argument. All science must be concerned about validity. All science must be concerned about designing its inquiry in such a way that validity is assured. Now, validity, what's another word for validity? We've used one, 2 or 3. What is another word for validity? Anybody?
Provable.
You're overworking the question.
True.
Truth. True.
Reliability.
That's another kind of validity. You're right, but basically validity is truth. So we're concerned about things that are true. Now, if I'm going to measure the height of American people, how many Japanese would I want in my sample? If I'm trying to discern the height of Americans, how many Japanese do I want in the sample? Come on, there's a hard answer to that.
A proportional number.
You bit the bait.
Sorry.
There's a big hook in it.
A proportional number of Japanese Americans.
Good point. I was thinking in terms of pure ethnic categories. This man's thinking in contemporary sociology. He's right. Very good. Very good. Maybe it'd be better if I'd use another illustration. If I'm trying to measure the height of kangaroos, all right, I got you now. If I'm trying to get the average height of kangaroos, how many apes do I want in my sample? That's easier, isn't it? Thank you. How many apes do I want in my sample of kangaroos? If I have any in there, it will invalidate, notice the word, invalidate my measurements. Right? So then the issue is, how do I assure validity? One of the most important things to be concerned about is to make sure that in my sample, I don't have inappropriate subjects. Recent graduates of theological education, their opinions about Karl Barth. How many first-year students do I want in my sample? Did you hear that? Someone said none. Why did you say none? Yeah, I said, wait a minute. The issue is graduates of theological education. What is their opinion of Karl Barth? It's invalid when I put first-year students in there. Is sampling important then? Sure. Sampling, which is one of the techniques, one of the procedures of good science, is important. Now, as a matter of fact, from a strict vocabulary point of view, that issue is not a sampling issue. It is the son of a sampling issue. Or sampling is the son of the bigger issue. What is the bigger issue then? Go to your vocabulary. Huh? Aha, good. It's a population issue. Because I have mixed my population out of which I sample. How many kangaroos would I describe in a population of giraffes? If my population is giraffes, what do I deal with in my population statement? The characteristics in general of giraffes. Now I'm going to measure giraffes and get an average height. How many giraffes are there in the world? Want to make a guess? Anybody has some approximate idea?
A few 100,000.
Several 100,000? Okay. Let's say several 100,000 giraffes in the world, and I can't get at them all. It takes too much time. Is it possible for me then to get an average height of giraffes? The answer is, it'd be a lot nicer to measure them all and divide by whatever that number was. But since we can't, what do? We sample that population. Now when I'm sampling the population of giraffes, what animals am I looking at? Again, I'm still stuck with giraffes, right? Now in my sample of giraffes, I'm just going to take the ones that are short because they're easier to measure. Do you detect a problem in my study? What is it? It's called a sampling problem, because I have introduced a factor that will guarantee that my sample will not be, and what's the magic word next? What will not be? Thank you very much. How many of you really felt comfortable with that? I heard it mumbling all over the room. Wonderful. Good. You're off and running. The issue of representativeness in sampling is very important. Now, what does representativeness mean? Here's the population. All the giraffes in the world. Here's the sample. I want this bunch, 20 of them, to be representative of this 100,000 of them. What do I have to be very concerned about? That they represent the range of characteristics that I find in the population. So what do I want? Do I want all short ones? No, I want short ones and tall ones. And I want dumb ones and bright ones. And I want boyses and girlses. Right? And I want old ones and young ones. I want my sample to be, again the word? Representative. Now, in descriptive research, representativeness is rarely achieved by random selection. Random selection is a kind of a catchword that a lot of people who've read just a little bit of research tend to use whenever they're talking about sampling. What is a random sample? Now that is a technical question and it requires a technical answer, but go ahead and try, live dangerously, die young. Pick it up anywhere. I promise not to make a fool of you. What is random sampling?
When you don't have any design in the way you are selecting the...
No, it actually has a high degree of design. Random can, in the ordinary common use of the word random, it can mean haphazard. But in science, random is a very strong word.
Every individual in the population has an equal.
That's the technical. Where did you learn that? It always delights me. The reason I ask that, and I'm going to be asking that of a lot of people, because a lot of people do bring previous knowledge in. Others really pay attention to the book, and some people do both, and that's better yet. Yeah, A random sample is one in which every case in the population has an equal possibility of being in the sample. Now, there are all kinds of ways to get a random sample. Let me just go around this room. I want to do an interview study. I've got time to interview about 3 people, and I've got a whole bunch of people around here. What is it? We got 20 people in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, all total bodies. All right? Now, I have time to interview about 3 or 4 people. How would I get a sample to interview? Let's say, first thing, let's get a random sample. Think of the easiest way to get a random sample of the people in this room. The easiest way. Not a very sophisticated way, but it is, believe it or not, it's scientifically responsible. How would I do it?
Draw names in a hat.
Draw names out of a hat. Thank you very much. Old child's trick, but it is very responsible. Until you get to about 100,000 slips of paper. But for this class, I can do it. Everybody writes his name on, and you got a card there, right? Same size card, same kind of characteristics, and drop it in. Not big cards and little cards and folded cards and flat cards, but all alike. Drop it in a hat, and we just scramble them all up and draw one out. How many would I need to draw out? I've got how much time do I have? Time to interview? 3. And I draw them out by random. Can you give me any idea who I would draw out by random of this group? If your names were all in a hat, who would I draw out?
Lily.
Why do you say Lily? By the way, that answer is right.
What was that?
The answer is right, but how did you get there?
It was just random.
And that's why it was right. He could have named anybody, and I'd have to say him. That's as good as any. Now, let's say that I draw one card and it's Lily. All right, I draw the next card. Who's that?
Anybody but
Anybody but Bob?
But Lily.
But Lily.
Oh, anybody but Lily is right. Anybody but Lily. As a matter of fact, it could be you. And when I draw the third, it could be you. You see a problem?
The chances are getting better as you go along.
You may get in there sooner or later, but you draw it. The point here is that when I draw at random, I am literally risking a concern that I haven't named, bad design. I shouldn't be randomly drawing from all the names. I should be randomly drawing twice. Once from the male names and once from the female names. Now why? Is there something magic that says women can't be in the same random draw as men?
Wouldn't another problem arise if we are doing also a study with internationals also, because that would create another group?
Gee, you're way ahead of me. You're dead right. And you're dead right for the same reason. Here's the point. If I'm doing an interview study in this class, the probability is that it's something that makes sense. You know, give me a break, gang, okay? These interviews make sense. But if I'm interviewing only the women, alleging that this is a random sample of this group, it may be technically a random sample, but it is a seriously biased sample, nonetheless. Which is why I would probably want to divide the group, and here's where you're right. If you want to stand up and make your point good and strong, we can all applaud because you're dead right. Whatever are the dominant variables that would affect the kinds of responses we would get on that question, on that interview, we ought to account for them. Now, one of these, of course, is we've got Americans and we've got non-Americans. We've got men and we've got women. We've got women who are non-American and women who are American, so that's a subdivision. And pretty soon, we're going to have to random sample till the point is we've got everybody in the room in the sample. Which is why we rarely use random sampling for the typical study that we do in small group analysis. What we generally do is to draw a representative sample. So in a representative sampling, we have all kinds of ways to go, but you want to spend the time in your textbook looking at representative sampling. One of the ways to do this is to identify the cells. Identify the cells that are, in other words, clusters of people that you would want to be sure to deal with in your sampling. I'm going to do these interviews. I really only have time to do 3, and I'd like to have it as small a number as possible, but I would like very much to get at some of the main variables in this evident group. All right, Lily, would you please stand? Now, Lily will give me 2 variables that are important. What are they? She's a woman, and she is non-American, or at least a parent international. All right. Somebody else stand or nudge your neighbor or something and give me somebody else that will add some variables to that that are significant. You, Bob, you've been nominated by that's several people. Now, what does Bob represent that Lily didn't?
He's male.
Male and
He's American.
American. All right. Now, Lily, look at these 2 and say, but if this is the whole group, we've got some things left out that are likely pretty important. What are they? Okay, nominate somebody else. Nudge them or grab them. Okay.
Cohort group.
Now, what do you represent that he doesn't?
Color.
All right, you're white, he's black, all right, but you're a man, he's man. You're American, he's American. Okay, now we got clearly the group biased in the direction of American responses.
And men.
Following? And men. All right, remedy.
Michelle.
Michelle. All right, now what do we got? We got a real problem now.
You got 3 Americans.
Too many Americans.
We got 3 Americans. We're not gaining on the ground on it. And you notice we're not going to be able to do a whole lot with it. Because you're American. We're not going to be able to do much about it. At some point, we're going to have to quit while we're winning. Because the more you ask to stand, the more likely we are going to hear from a lot of others, not just, this is what you do in representative sampling. And obviously, if you keep going, we have the whole population standing, because you are the population, this group. As I said, I wanted a random sample of this group. My population is what again? This group. My sample is a selection of people who will give me range and variety within this group. Does that make sense? Now, is that as representative a sample as a random sample of 4 people would have been? Very likely it is. Very likely it is. Thanks, folks. Sit down. There is a technical thing here that we have to understand about the wonders of the random sampling process, however, not to throw it clear out. When I have a large population, and it is largely similar people, I can randomly sample it. Large population of comparable people. And especially if I don't have access to them enough to know the peculiar characteristics that I might want to represent in my sample. For example, I am currently working for a coffee company. Let's say I'm working for Seattle. That's a big company. Starbucks. And I want to get a sampling of the coffee buying habits of people that show up in their coffee shops. I want to find out how many cups of coffee they drink at home, in addition to how many they drink typically in a Starbucks station per day. You got the picture? Okay, now, I don't know how many people Starbucks deals with every day, but I'm sure not going to be able to get at them all. I'm going to give a questionnaire to a random sample. Now, what do these people have in common? They're Starbucks coffee drinkers. I really don't know much more about them than that. I probably can't know much more about them than that, so I'm going to randomize right there. How many people would I have to get a real clear picture of the coffee buying habits of Starbucks customers. Let me just suggest that there are 1 million coffee drinkers that buy some coffee each day at Starbucks across the nation and across Canada. Let's say 1 million. How many people do I need in my random sample? Pardon?
How many can you afford?
Well, let's assume I've got a good bit of money, but I'm not going to be silly about it. But I'm going to give you another criterion. I want as small a sample as I can get by with statistically. You may not have picked this up in the book, but I think it's there somewhere. It's one of those little gems of wisdom. If you're dealing from a largely homogeneous group, by the time you get to 25, you have the whole group. And there's a statistical argument for this that's really very, very clever piece of statistics. It's somewhere between 25 and 29, somewhere along there, in most distributions. If the variability is not great in the population, a random sample of between 25 and 29 will represent most of the variability. Now, would you be satisfied if you were a scientist at looking only 25, 27, 29 Starbucks folks, that they're going to give you a picture of 1 million a day? The answer is the more highly trained you are, the more apt you are to be satisfied with that. The amateur is going to be very dissatisfied. That doesn't sound like enough. And let's say the Starbucks increases, and we look at this research again, and now we've got 2 million people a day at Starbucks. Now how many do I need in my sample? The answer is either 25 or 50. And I'm going to insist that you put your hands up on one or the other, and we're going to wait and put a finger on you if you don't. All right? What is the answer? I've got 2 million people now, double it. And I'm going to repeat the study. Now do I need 25 or 50? How many say 25? You're correct. Now, where did you come up with a stupid idea like that? Because I double the one and I don't double the other. What's the logic for that?
They're still representing, the 2 million still represented, or it's still homogeneous.
Aha! As long as the 2 million is still homogeneous in the same way that the first million was, I can still rely on the general formula that says when I get to about 25 to 29, I have accounted for most of the variability. Now let me just show you this, how this process works. Someone please stand up. Anybody? 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 Let's go. Stand up. All right. Now look at this man. Examine how he's dressed.
I'm a modern.
Somebody else stand up. Anybody? Come on, come on, come on. Look at how he's dressed. Are these people dressed similarly or dissimilarly?
Similarly.
Similarly in what respect?
Casual.
Pants and shirt. Dissimilarly in what respect?
Color.
Color,
Size.
button pattern shirts, long sleeve, short sleeve. Come on, give me some more.
Size.
Belts.
Size, right? Okay. Type of belt. Somebody else please stand up. Somebody else please stand up.
Which one are you
I
talking
said
about?
fabric, I said fabric.
Take a look. You've got 3 up. You've got 3 up now. 1, 2, 3.
My pants.
Are we getting more variability? Are we getting less variability? We're getting more variability. We've got a monocolor with pockets, monocolor with flat pockets without. Trousers and shirt, that's common. So we got commonality, we got non-commonality, we're getting difference, we're getting similarity. Somebody else please stand up. Come on. All right, thank you very much. Now, are we getting, as we go, are we getting more variability or less variability case by case? Think about it. Look at anything you want to look at. Look at anything you want to look at. Let's get another person up. Please, another one up. Here comes our first preacher. Okay. Now we got some more variable. Let's have another one up, please. Now, clothing is really quite a varied variable, but you notice we're getting a lot of similarity here. In combination, we're getting this pants and shirt thing, we're getting this belt thing, we're getting this different arrays. We can always find peculiarities. But in general, are we getting more variability as we go along? In terms of each case gives us more variability than the last case gave us? Each case from now on is going to give us less new to look at than the last case did. Give me another one up, please. Anybody? Let's go. Thank you very much. Look at this one. Oh my gosh. 3 buttons, 3 buttons. Gray, gray. He's the only case with a dark color. Very interesting. We get a little bit of variability here. Boy, we had to dig for it, didn't we? All right, let's have another one up. Okay, we've got this shirt, this long sleeve shirt. We've got this monocolor shirt without a tie, monocolor shirt with tie, belt. Now he adds us a little bit of variability. Here, what am I saying? We need them so far. We need them so far. Let's keep going. Somebody else. Okay, there she goes. All right. Do we need her?
Yes.
Yeah. All right. Another one.
Yeah.
Do we need her?
Jeans.
No, seriously.
Yes.
Yeah.
Yeah. We need another.
Yeah.
Jeans.
Another one. Are we gaining variability at the same rate, or are we beginning to taper off?
Taper off.
Another one up, please. Okay. It's our first jacket. Still gaining. Sweater, upper, sweater, upper, short sleeve, short sleeve. Similarities, dissimilarities. Another one up, please. 2 buttons. Really having to dig now, aren't we? Are we getting close to 25? Do you see what will happen by the time we get to 25? Let's see, even if we got 400 people doing this. You see it? That's the point. You need the variability up to a certain point, and then it begins to taper off so much that you've really got it up there. Thanks. Sit down. I just wanted you to feel that. So when we talk about a process of random sampling, after a certain point, the increasing of the size of that sample doesn't make a lot of difference if they are essentially homogeneous to start with. Now, we had a non-homogeneous group to start with. I would say that the primary variability there was gender. So we really should have left the women out of this or left the men out of this. And if you left the women in, how many would we need in our sample before we really see that drop off at a certain number?
Some wearing dresses.
If we had 50 in our sample and left the women in it, because we really have 2 different, largely homogeneous populations of women and of men. And that's the kind of reasoning you have to do when you're doing random sampling. Now, what happens if you have a lot of variability? I've got Canadians in the sample, I've got Canadian women, Canadian men, I've got American men, American women, I've got immigrants, I've got male immigrants, female immigrants, I've got immigrants that have been here a long time, immigrants that are new here. How many do I need in my sample? 25. 25. 25. 25.
If you're talking about dress, that is really quite a commonality. If you really want variation of dress, you're going to have to bring in some Indians and people.
I'm not after variability greater than the group. See, we were sampling from a given group. And from a given group, 25 will give it to you. But the minute I'm serious about random sampling from a group that is largely non-homogeneous, I'll end up with a huge number in the random sample. So what they do generally today is not resort to random sampling, but very sophisticated representative sampling. Are you familiar with the way judgments are made about how much money is paid for television shows? how much the producer makes on a given show. How is that determined? Determined by Nielsen or one of the other major rating companies. And these companies will give you a rating that tells you how many people are watching that show as of now. Because we have the data from last Thursday night. And 80% of the market was in this one show. And boy, those guys are going to be able to command a whole bunch of bucks for that. Got it? Where does Nielsen get its numbers? Seriously, seriously, where do they get their numbers? Do you have any idea? Now, one way to do it would be every week they send out interviewers every half hour and check, go to the door, knock, what station are you watching? They don't do that. Much more sophisticated.
There are boxes in people's
Channel boxes.
TVs.
They have sensors attached to the television sets of millions and millions and millions of people. No?
No, it's not. It's only
300.
What actually is it?
10 to 12,000 or something like that?
It's a heck of a lot less than that.
About 1,200.
About 1,200 people nationwide. Because they know exactly what they're looking for in terms of a national representation picture. And they know which families are representative of the large set, so that they multiply those families by larger factors. So the whole thing's done actually by sampling only about 1,200 different types and then multiplying proportionally to get the distribution. Does that make sense? What is that technique called in general? That's called sampling.
Survey.
Why do you do sampling? In order to get representation, which will then make your research more valid. All of those concerns are validity concerns. Does that make sense? Somebody says we need validity. Who started us off on that kick? Yes. And it gets us into all that stuff. After break, we're going to get into a whole lot of additional stuff to it, okay? And we're going to talk through a lot of the terminologies you were asked to look at. We're going to look at some basic guidelines, and we're going to get started at a run after break. Now you can have, synchronize your watches. You can have, let's see, 1, 2, 3, 4, 7 minutes and a quarter. Well, let's liberalize it a little bit. You're doing real well tonight. Let's go again at 20 till. How's that sound? Take a stretch, run around, go out and get wet in the rain, whatever you need to do.